Hello friends, today I am now going to discuss differentiability of a complex function. So what do you mean by differentiability of a complex function? But as usual, before discussing the differentiability of a complex function, we should know first what is differentiability of real function. Differentiability of real function means if you have a function f of x, mathematically we will all know that it can be written as f dash x equals ddx of f of x, that we all know. But how can we write differentiability of a real function in terms of limit? In the limiting terms, we can write differentiability of a real function can be written as limit, suppose delta x tends to 0, f of x0 delta x minus f of x divided by delta x, such type. Similarly, in case of complex function, mathematically we can write differentiability of a complex function can be written as f prime z limit delta z tends to 0. Always remember, not here z tends to 0. Always remember here delta z tends to 0. F of z plus delta z. You have a function, complex function f of z. So the differentiability of that complex function f of z can be written as limit delta z tends to 0, f of z plus delta z minus f of z divided by delta z. That it is the mathematical definition of differentiability of a complex function. So how can you represent the differentiability of a complex function in an Argand plane? So let's write that. Suppose we have an Argand plane, complex Argand plane. Suppose here the limiting value is z0. Suppose you are coming to this plane in such way, z0 plus delta z, z0 plus delta z, z0 plus delta z. So that there are infinite ways. There are infinite ways of the approaching value z0 here. So if we take some examples, then it will be more clear about you that how to take differentiability of a complex function by taking example. Let's take example. Suppose we have function f of z equals z cube. Okay. So how can we say that it will be differentiable in nature? How can we say? We can say how. So let's start. Limit f of z is z cube. Okay. Limit delta z tends to 0. Always remember, delta z tends to 0, f of z plus delta z minus f of z divided by delta z. Yeah, this is a mathematical definition. So if we write z cube, let me write a clear notation z cube. So if we write z cube in such a notation, then we can write here limit delta z tends to 0, z plus delta z whole cube minus z cube divided by delta z equals limit delta z tends to 0, z plus delta z whole cube minus z cube. Now if we break this, z cube plus 3z square delta z minus plus 3z delta z square plus delta z whole cube minus z cube. Let me write in a good slide, in a blank slide. I should write this. So limit delta z tends to 0. If we break this, we will get z plus delta z whole cube as z cube plus 3z square delta z. Why it's not working? Plus 3z delta z whole square plus delta z whole cube minus of z cube divided by, now it's working, divided by delta z. So at z cube minus z cube, it will be cancelled out. Yeah, z cube minus z cube, it will be cancelled out, and delta z very small quantity. It will be also negligible. It will be cancelled out to 0. And another thing that is, we know, if we take delta z as common, now write it clearly, write it them after cancellation, write it clearly. We can write limit delta z tends to 0. If we take delta z common, okay, we will get what? We will get 3z square plus 3z delta z, and here delta z will be cancelled out. Now delta z tends to 0, put it here, it will be also cancelled out to 0, so we'll get 3z square. So we are getting the differentiability of z cube as 3z square. So how can we say that it is differentiable in nature? So we can conclude that if function fz doesn't depend on the path delta z, then it will be what? Then the differentiability will be exist, because it will be path independent. Here fz equals z cube, here it is independent of delta z. So that's why it is differentiable in nature. Let's take some examples to let me clear you. Here I am giving you one important trick to remember you. What is the trick? Formula 1. Z to the power n means if z to the power positive integer, n equals integer, z to the power positive integer it will be differentiable. If we have a function such that z to the power positive integer is in the function, then it will be differentiable. And if we have z to the power negative integer in the power, z to the power negative integer, remember it as a trick, negative integer, negative power here it will be, then it will not be differentiable. That means if a function contains positive integer power of z, then it will not be differentiable. But if it contains if a function contains positive integer power of z, then it will be differentiable at every point. But if it contains negative integer power of z, then it will be not defined. It will be not differentiable at z. Suppose, let's take an example. It will be clear. Suppose you are taking fz equals z square. Here z to the power positive integer is there. That means it will be differentiable. It will be differentiable at every point. But if we take negative integer power means, suppose if we take fz equals z to the power minus 2, that means what? 1 by z square. Z to the power minus 2, that means what? 1 by z square. Then it will be not differentiable at z equals 0. It will be not differentiable at z equals 0. Similarly, let's take fz equals z to the power minus 3. Fz equals z to the power minus 3. It is not defined at z equals 0. That means it is discontinuous at z equals 0. When it is not defined, it is not, let me write more clearly. Suppose fz equals 1 by z cube, means z to the power minus 3, negative integer power of z. That means what? At z equals 0, it is not defined. Whenever it is not defined at z equals 0, that means what? It is discontinuous. It is discontinuous at z equals 0. Whenever it is discontinuous at z equals 0, that means it is not differentiable at z equals 0. So remember the trick that whenever we will positive integer power of z, that will be differentiable, but whenever it will be negative integer power of z, it will be not differentiable. Let us take another example. By this trick you will calculate so many problems so quickly. Suppose we have a function fz equals 1 plus z by 2 1 by into z minus 2. Okay, so at the point z equals minus 2 and at the point z equals plus 2, in both this point, at both this point, fz will be not differentiable. With fz is not defined. Fz is not defined at z equals minus 2 and z equals plus 2. It is not defined means it is not discontinuous at z equals plus and z equals minus, z equals plus 2 and z equals minus 2. It is not defined, so it is not discontinuous. That means it is not differentiable. Not differentiable at z equals plus 2 and z equals minus 2. Let us consider a series. Let us consider a series so that it will be cleared more. Suppose we have a series f of z equals summation over, let me write clearly, f of z equals summation over n equals 0 to infinite n z to the power n. Here it is containing positive power n greater than 0. Here it is containing positive power of z. That means this function will be differentiable. Similarly, if we take fz equals sin z, if you break sin z, what you will get? You will get z minus z cube by 3 plus z to the power 5 dot dot dot. So positive in power of z, that means it will be differentiable. So that's it. Now let's discuss if we take any the complex conjugate power of z. Complex conjugate power of z means, suppose we know that z is differentiable at some point. If we take z star, if we take complex conjugate of z, that means z star. Z means x plus iota y. Z star means x minus iota y. So whenever you will take this z star, so how can we approach whether it is differentiable or not differentiable? We have to see that whether the delta z tends to 0, whether the limit is independent of delta z or not. Whether the limit is independent of delta z or not. So let's take limit delta z star tends to 0. Sorry, delta z tends to 0. Limit delta z tends to 0. We can write z plus delta z whole star minus z star divided by delta z. Yeah. Limit delta z tends to 0, z plus delta z whole limit delta z tends to 0, z plus delta z whole star minus z star divided by delta z. So if you take z equals x plus iota y, so delta z equals delta x plus iota delta y. Okay, and delta z star equals what? Delta z star equals delta x minus iota delta y. Okay, so after evaluating this z plus delta z whole star minus z star, after evaluating this, we will get what? We will get limit delta x tends to 0, delta y tends to 0, delta x minus, and put here delta y equals m delta x, delta x minus m delta x divided by delta x plus m delta x. So if you take common delta x, you will get here 1 minus iota m divided by 1 plus iota m. So now here you are getting what? Here you are getting it is depending on m. Now here I have to tell you one important theory of here. If a function is differentiable, differentiable, then its limit will be exist. Then its limit will be exist. So here you are saying that the limit is not independent of path. The limit is path dependent. As the limit is path dependent, so here delta z tends to 0. It is also path dependence. Here delta z is also the function is delta z dependent also. So if z equals z star is not differentiable. Not differentiable. So what we can conclude from here? We can conclude from here that imaginary part such as a function f of z, if it contains z star, means complex conjugate of z, that will be not differentiable. That will be not differentiable. If a function imaginary part of z, then it will be not differentiable. So we can say in line, that if z equals sin z star, if z equals suppose z star, if z equals suppose cos z star, whatever, here it will contain z star, whether it will be containing z star. If z equals cos z star, real part of x, it is also not differentiable. Why? It is also not differentiable because half into z plus z star. That means if a function fz containing z star, then it will be not differentiable. It will be not differentiable. So we can say the points, that points related to limit, continuity, some points related to limits, continuity, and differentiability. So if limit exists, we can see that from the previous lecture, from the previous video, we see that if limit exists if the limit is path independent. If the limit is path independent, the function which is not continuous, the function is not differentiable. If a function f of z not continuous, then it will be not differentiable. If a function is continuous, but vice versa, we can't say properly. If a function, suppose it is continuous, it may be or may not be, both probabilities there. It may be or may not be differentiable. If limit exists, then it is path independent. Path independent means limit exists. If a function which is continuous, it may be or may not be differentiable. But if function is not continuous, then it will not be surely differentiable. It will not be differentiable. But if we say another point, the most very important point, if a function fz is differentiable, then we can say that limit will exist and the function will be continuous both. If a function is differentiable, then limit will be exist and it will be continuous both. Suppose take an example. Suppose take fx equals mod x. Yeah. If we take fx equals mod of x, mod of x is what? Mod of x, the graph of mod x will be what? Mod of x graph will be such that here x positive region of x, here x greater than 0, here x less than 0. Okay, mod of x equals x for x greater than 0 equals minus x for if x is negative. If x, here x greater than 0, here x negative. So we can say that it's very important, it's very interesting example. Let's take this example. So here we can say f of x equals mod of x. F of x equals mod of x, here x. So we have to decide whether it is discontinuous or continuous or differentiable or not differentiable. So f of x equals x. X is positive and whether x less than 0. We'll discuss it whether it is differentiable or not in our next video. You all say in my comment box whether it is differentiable or not differentiable, continuous or discontinuous, or its limit exists or doesn't exist. So that is it for today. I'll be waiting for your comments. So thank you so much for patiently watching my video. So we can say that this is going to be very interesting series, complex series. So stay connected for the whole series. Bye. That's it for today.